At this time, we'll be doing Heat Pump Diagnostic Module 3 and Module 4. Now, please remember, if this is a live session, we would be recording the live session, but this is a recorded only session today. So in this portion of the program, we're going to be discussing defrost controls for our heat pump. And please follow along as we talk about the following key points. We're going to talk about defrost control principles, basically the difference between a time temperature and a demand defrost control. We'll talk about electrical inputs and outputs, thermistors and the use of sensor tables for troubleshooting, and forced defrost modes. So, defrost control principles. If you'll please refer to your handout or your workbook and find this text field, you'll notice that it has some very important information concerning time temperature as well as demand defrost controls. The main thing about a time temperature defrost control from a review standpoint is the fact that it will continually monitor the Y signal of the compressor. In addition, the time temperature control has a normally open set of contacts, or more specifically a defrost control switch that's going to close electrically on a drop of temperature. Now this switch is going to be mounted on the lower coil pass of the outdoor coil. So in the heating mode of operation, as the outdoor coil becomes cold, because it's acting like an evaporator in the heating mode of operation on a heat pump, as that normally open switch gets cold, it will close on a drop of temperature. As that temperature closes electrically, it will then enable the time temperature defrost control. Then after that switch closes, it's going to be monitoring compressor runtime. Now it should be noted the compressor runtime after that switch closes will be accumulated compressor runtime. Now that is field selectable, typically 30, 60, or 90 minutes. The technician will be able to select how much compressor runtime after that switch closes before defrost. Once that switch closes electrically and the accumulated compressor runtime has expired, the unit will go into defrost. Now this is a very important principle, team, with all defrost controls, that on a heat pump, when it goes into defrost, it doesn't matter if it's a time temperature control or a demand defrost control. Once it goes into defrost, the outdoor fan shuts off, the reversing valve switches into the cooling mode of operation, and so to defrost the outdoor coil, we go into the cooling mode to warm the outdoor coil up, and then we also energize the auxiliary heat output to bring auxiliary heat on in the conditioned space so we don't cool the conditioned space down excessively. So the time temperature control, it utilizes a normally open switch. It's going to close on a drop of temperature to initiate defrost. Now the demand defrost control is a little bit different in the fact that instead of using a normally open clicks-on type of temperature sensing switch, it's going to have at least two sensors. Those sensors will be an ambient sensor and a coil sensor. Now the ambient sensor will literally hang out into the atmosphere below the control panel to sense air temperature, and the coil temperature sensor on a demand defrost control will be physically mounted to the coil, the outdoor coil, to sense the coil temperature. Now it should be noted that demand defrost control is typically more efficient because it's going to defrost more on an as-needed basis instead of just strictly being based on temperature and time. So the demand defrost control has two sensors. It will continue to monitor the Y signal or compressor operation, and it does have some time backup as well in case we have a sensor failure. And just like a normal defrost control, all defrost controls, once the temperatures have come to the point where it's time to defrost the demand defrost control, once the temperatures are met for defrost, it'll shut the outdoor fan off, energize the reversing valve and cooling mode of operation, and then energize the auxiliary heat so we don't overcool the conditioned space. It should be noted also that on a time temperature control, it has a clicks-on temperature control, but on a demand defrost control, the demand defrost control with the two sensors, it's constantly monitoring outdoor air temperature and coil temperature. Now it should be noted on the demand defrost control, it'll go into defrost when there's a difference of temperature between outdoor air temperature and coil temperature. Now this is a predetermined, pre-engineered value. It's called a defrost control curve, and that will differ based on the tonnage of the outdoor unit. So based on the delta T, or the time temperature difference between outdoor air temperature and coil temperature, will determine when the demand defrost control will be energized or will be utilizing the defrost control function. Now, some tools are going to be needed to check the defrost controls. You're going to have a good high quality voltometer capable of DC voltages. And we're also going to recommend that you have needlepoint meter leads, so that you can actually check harnesses and you can check the voltage on those harnesses with them plugged into the board. In addition, an accurate electronic temperature probe is going to be needed to take the temperatures of the outdoor air temperature and the coil temperatures and those functions on our demand as well as our time temperature controls. And then finally, a good high quality temperature clamp for your electronic temperature probe is recommended. We do not recommend laser or laser type of temperature probes. They're not accurate enough for this type of function and this type of measurement. So we recommend a touch probe or a type of probe that you physically strap onto the refrigerant line or clamp on are the recommended temperature probes. And again, time temperature defrost control will utilize a single normally open switch. The demand defrost control will utilize 2 sensors, ambient and coil sensor as a minimum. As we take a better look at our demand defrost control today, we're going to be discussing some of the things that are going to be unique to it. Specifically, the demand defrost control and the advanced defrost control will monitor the following. It will monitor accumulated compressor runtime via the Y circuit or the Y signal from the thermostat for compressor operation for backup functions. It will always have an outdoor coil temperature sensor and an outdoor ambient temperature sensor. In addition, the advanced defrost control will have a discharge line sensor as well for advanced features. Some of the base core engineering of all the defrost controls are going to be as follows. There will have to be a minimum of 40 minutes between defrosts or since the last defrost. This prevents the unit from short cycling in case we have a bad sensor. The outdoor temperature has to be below 40 degrees before it will initiate defrost. In addition, on the demand defrost control, the standard demand defrost control, when the coil temperature reaches 55 degrees Fahrenheit or 80 degrees with a special position on number 4 of P5 jumpers, it will terminate defrost. So defrost termination will be when the coil temperature reaches 55 degrees Fahrenheit, or a maximum defrost time of a 14-minute backup is reached prior to the liquid line reaching 55 degrees. So let's take a look at that demand defrost control right now. This is just the standard demand defrost control. So in your workbook or your handouts, find the picture of this demand defrost control, and we're going to encourage you to please follow along as we talk about all of the inputs and all of the outputs. So starting out with the low voltage input. Now remember, team, we've removed all the wires off of this board and all the harnessing off of this board for educational purposes. But in this area right here where you have your CROY and etc., those will actually be pigtails to hook up your 24-volt wires from the thermostat and the indoor unit. So let's take a look at those together. So starting out with C terminal or C wire, that's typically a blue wire, is 24-volt common. R terminal is 24-volt hot, and that's typically a red wire. Now team, this is extremely important. There has to be power on the board all the time outside for it to function. Even in the summertime, it has to have 24 volts on it. So it's important that we have 24 volts between C and R terminals, or common and red terminals, all the time on the board. O terminal, or that orange wire, that's going to be an orange pigtail, is our input from the thermostat for reversing valve operation. Now remember, team, on a heat pump thermostat, we energize the O terminal on our Champion equipment. We energize O terminal, or the orange wire outside, for reversing valve operation in the cooling mode of operation. Y terminal is an input from the thermostat demanding or calling for compressor operation. So Y, typically a yellow wire on the outdoor unit, is going to be for compressor operation. W is an input from the thermostat to the outdoor unit calling for supplemental heat. Now remember, team, on our demand defrost controls, because of the unique features of the demand defrost control, the Champion demand defrost control, we can allow the outdoor unit to make intelligent decisions on when to stage auxiliary heat. And so the W input from the thermostat outside, going straight outside, will be a demand for auxiliary heat from the conditioned space. And then based on the location and position of some relays outside, we will then have a W output from the outdoor unit. That W out is actually an output from the board for supplemental heat inside. So remember, we take W from the thermostat straight outside to W, and then the board outside makes decisions on when to stage auxiliary heat inside. So W out will be brought in from the outdoor unit to energize auxiliary heat when we have a demand from the conditioned space for auxiliary heat. It should also be noted that W out will be utilized in the defrost mode of operation to energize the auxiliary heat during defrost. So W out is a very, very important output that we remember has to be brought inside to the auxiliary heat, whether it's the heat strips on a air handler or if it's a gas furnace. W input for auxiliary heat to energize during defrost. As we take a look at our demand defrost control and we move around the board, we see we have two inputs, HPS and LPS. That's high pressure switch and low pressure switch. Those are safety circuits, and they will be harnessed in from the factory on HPS and LPS for high pressure and low pressure switch. The RV terminals, or the RV pins on the defrost control, are two wires that go down to the reversing valve, and those wires will energize the reversing valve in the cooling mode of operation. It should also be noted that during defrost mode of operation, the RV terminals will also be energized to energize the reversing valve into the cooling mode of operation during defrost. The CM terminals or wires on the board are going to be utilized to energize the compressor contactor coil on a call for compressor operation. So anytime we have a Y signal to the board from the low voltage wiring, Y signal to the board will then interpret that Y signal as a demand for compressor operation. Then, as long as the anti-short cycle or the defrost control with its built-in anti-short cycle timer of 5 minutes, once that has expired, we will then output 24 volts on C and M to bring the compressor contactor coil on. So remember, team, it's actually two functions. Number one, we get a Y signal on our low voltage wire from the thermostat and indoor unit. We get a Y signal for compressor operation. Then the control board outside, if the anti-short cycle timer, in other words, if it's been 5 minutes or more since the last time the compressor was running, this anti-short cycle timer will be expired after 5 minutes, and that Y signal will then be converted into a 24 volt signal on the board for C and M to bring the compressor contactor coil on. So this is an important concept. The board actually has some built-in protection for anti-short cycle timing. So if the thermostat should call for compressor operation in less than 5 minutes, the board's going to hold that Y call or that compressor demand before it allows the compressor to come on for safety. Next to that, we see we have a coil and ambient sensor inputs. Those coil and ambient sensor inputs will have sensors actually hooked up to those. Now, if you look closely in the picture, you'll notice the coil sensor pins are actually closer together than the ambient sensor pins. And the reason we do that on our Champion equipment, this prevents the technician from hooking up the sensors improperly if he changes the sensor out. So the pins are actually a different spacing to prevent inaccurate hookup or inaccurate plugging on to the board. It also should be noted that if you remove a sensor, these sensors from the board, you should read 4 to 5 volt DC between the pins. So if I was to take my voltmeter and go to DC volts and go between the two ambient pins, I would see 4 to 5 volt DC. Or if I went between the two coil pins, I would see 4 to 5 volt DC. So this is an important concept to check board integrity. If we've got 24 volts on the board between C and R on the low voltage wiring coming in, if we've got 24 volts powering the board up, we should have 4 to 5 volt DC on those ambient and coil sensor pins. If we do not, then we know we have a bad board, replace the board. However, if we do have 4 to 5 volt DC on the sensor pins, and we do have 24 volt going to the board, and we can force a defrost on the board, then the board's okay. So that's a quick little troubleshooting tip when you're coaching your contractors. As we move to the center of the board, we see we have a defrost curve or defrost control curve. It will come in some position from the factory, typically on number 1 setting. However, it should be noted that number 4 setting has a temperature termination increase up to 80 degrees. So we're going to recommend that leave it alone from the factory, unless you have a real good reason to move that pin to position number 4. It should be noted that from the factory it will be in a position other than number 4. But number 4 is an 80-degree termination point that can be field selected for special application. Here we have our condenser fan relay. The condenser fan relay, you'll notice, has got it says high voltage as a warning, and we want to make sure everybody understands that the condenser fan relay is the only high voltage point on this board. This high voltage relay actually breaks the condenser fan circuit electrically when we go into defrost. This is how we shut the outdoor fan off during defrost. But please be noted, let it be noted, and be sure and coach our contractors and our customers. These are high voltage terminals, so please be careful when handling the board if the power is on outside. Now, from a troubleshooting and from a safety standpoint, we always recommend shut the power off on the unit outside to de-energize those high voltage contacts for safety. As we move around to the left side of the board, we see we have a status LED. This status LED will help assist the technician in troubleshooting problems on the board. We can receive flash codes on the status LED based on what's going on with the board. Please look at the factory technical service information for more details. Right above the status LED, we have 2 test pin jumpers. And so those test pins, we're going to jumper those test pins for defrost operation. Now, it should be noted, if you jumper those test pins for more than 2 seconds, you'll bypass the anti-short cycle timer. And as long as we have a Y call present for compressor operation, if we jumper those test pins for 2 seconds, we'll bypass the anti-short cycle timer. Now, it should be noted, if you jumper those pins for less than 2 seconds, nothing happens. Now watch this. If you continue to hold that short between those test pins. Now remember, team, that when you short those test pins, you can use a jumper wire. You can use a key. You can use a coin. Don't be afraid for it shocking you, because the truth about it is it's only it's low voltage DC, so it's not going to shock you. So you can use any sort of jumper to jumper those test pins. Now remember, if you jumper the test pins for less than 2 seconds, nothing happens. If you continue to hold that short more than 2 seconds, you'll bypass the anti-short cycle timer. In addition, if you continue to hold that short 6 to 9 seconds, it'll go into a defrost. Now, it should be noted, as long as you hold that jumper, it ignores the sensors. In addition, if the coil temperature is above set point, when you remove the jumper, it'll come out of defrost. Or if you lose the Y signal for compressor operation, that will also terminate defrost. All of our demand defrost controls are going to utilize some sort of thermistor sensors. And so the demand defrost control will have an outdoor temperature sensor, also called an ambient sensor. It'll also have a coil or liquid line sensor as well. Now, as we take a look at where those sensors are hooked up again, we see it says coil and ambient. Now remember, team, if you remove the sensors from the board, you should read 4 to 5 volt DC on the board, more specifically between the 2 coil sensor pins and between the 2 ambient sensor pins, 4 to 5 volt DC with nothing plugged on. Now, those sensors are specific to each defrost control. However, the nominal calibration point for all of our sensors on our residential Champion equipment will be 10,000 ohms at 77 degrees. So if I remove the sensor from the board and I take my ohm meter and I subject that sensor to 77 degrees, it should read 10,000 ohms. In addition, we also have some sensor charts that we can look at. And at this time, we're going to do some examples together with everybody. But remember, when you look at the sensor chart, you're going to have some tools to make it work. So we recommend a voltometer, excuse me, with DC capability, and needlepoint meter leads are recommended. We also recommend that you have a good high-quality electronic temperature probe with a temperature clamp so that you can read refrigerant line temperatures and outdoor air temperature accurately. So as we take a look at our ambient sensor chart, please take a look in your handout or your workbook, the ambient sensor chart. You'll notice there's going to be some temperature columns, some resistance or ohm columns, and some voltage DC columns. So the way these charts work, and they all work the same, you find the temperature that you've measured on either outdoor air temperature or refrigerant line. So let's do an example together. Let's say it's 40 degrees outside on our ambient or outdoor sensor chart. At 40 degrees, if I remove the sensor from the board and I take my ohm meter, it should read 26,092 ohms, unplugged off the board. However, if I take that same sensor, that ambient or outdoor sensor, and I plug it back onto the board, and I take my needlepoint meter leads and kind of sneak into the back of the sensor plug with it plugged back onto the board, at 40 degrees, the DC voltage should be 1.58 volt DC with the sensor plugged in. Let's do another example. Let's say it's in the middle of the summertime and it's a hot day and it's 100 degrees outside. So referring to the ambient sensor chart, if it's 100 degrees outside, I've measured 100 degrees and I remove the sensor from the board, I can take my ohm meter and my sensor should read at 100 degrees 5,774 ohms with it unplugged off the board. And then if I plug it back onto the board, we see it reads 0.47 volt DC at 100 degrees outside. So this is a very important check the technician needs to make if they're checking thermistors or sensors. And you'll notice that in your handout or your workbook, you're going to have an ambient outdoor air temperature sensor chart. You'll also have a combination chart with a bonnet sensor on top if you have a dual fuel situation to where you've got a furnace and a heat pump outside and you have an optional bonnet sensor. We give you a bonnet sensor chart. And below the bonnet sensor chart, you'll see there's a liquid line chart. Right, and this is your coil sensor. And so let's do an example. Let's say that coil sensor is reading a 80-degree liquid line coil temperature sensor. As you take a look at that liquid line coil temperature sensor at 80 degrees, if you remove that sensor from the board and ohm it out with your ohm meter, it should read 9,299 ohms. But now hang on a second. If you plug that sensor back onto the board at 80 degrees and you sneak your needlepoint meter leads into the harness behind that sensor, you'll notice that it reads 0.60 volt DC with it plugged back on. So all the charts, they work in a similar fashion. You look at the temperature, you read the resistance with it unplugged on the board, off the board, you plug it back onto the board, and then you can then read voltage. And then the final chart that you'll have in your handout or your workbook is a thermistor sensor for the discharge line chart. So the discharge line is going to be hooked up on our, oftentimes on our advanced defrost controls, they will use a discharge line sensor as well. So let's do an example. Let's say that discharge line or the hot gas line off the compressor is 200 degrees, 200 degrees. We see that if we unplug the sensor from the chart, if we unplug the sensor from the board, referring to the chart at 200 degrees, the resistance would be 823 ohms. If we plug the sensor back onto the board at 200 degrees on our discharge line sensor, we see that it would be 1.64 volt DC. So all the sensor charts, they work the same. You find the temperature, You unplug the sensor from the board. You can then read the ohms on that sensor with it unplugged from the board at any given temperature. You can then plug it back onto the board and read the DC voltage at any given temperature based on the sensor and the chart you're looking at. So remember, team, it's very, very important to have the proper sensor chart when you're looking at testing sensors. And please, by all means, coach your contractors and coach your customers on the proper use of these charts, and coach them on making sure they've got the proper tools as well. At this time, team, we're going to go ahead and look at heat pump diagnostic module number 4. And in this module, we're going to be focusing on the advanced defrost control, Now, the advanced defrost control has some very unique features, and we're going to go through each individual component and every input and every output as we did on the previous control. So starting in the as you take a look at it, one of the things we'll notice on the advanced defrost control is it is communicating capable. If you take a look at the upper left-hand corner, you'll notice it has COM terminals, and so that tells you immediately that the advanced defrost control is communicating capable. In addition, this advanced defrost control is also 24-volt capable. So we'll find a variation of this board, for instance, on our HL19 series of heat pumps. It's a 2-stage heat pump, and it's got a variation of this advanced defrost control as an example. Now, it should be noted that the advanced defrost control has some minimums between the last defrost, just like we had before, of 40 minutes. In addition, it will have an outdoor sensor that has to be below 40 degrees before we can initiate defrost, and the coil sensor has to be below 40 degrees before we can initiate defrost. In addition, on the advanced defrost control, the defrost termination point will be 80 degrees instead of our previous control board of 55. This is 80 degrees on the advanced defrost control. And the maximum timeout, or the maximum defrost time of 8 minutes, if that is reached prior to the liquid line reaching 80 degrees. So our backup time is 8 minutes, and our defrost termination point on our sensor is 80 degrees on the advanced defrost control. Some advanced features that we have on this particular control, in addition, are a field adjustable balance point, a field adjustable low temperature cutout for the compressor, a hot heat pump feature, a pipe freeze timer, and a fossil fuel capability from the outdoor unit. So as we take a look at the board a little bit closer, starting at the upper left-hand corner, we had mentioned earlier, this is a communicating capable board. And so if you hook this board up communicating, you'll utilize one of those COM ports up there. There's actually 2 ports. They're parallel ports. They're the same port. Electrically, it's just that we provide 2 of them. One of them is for testing, and one of them is for actually hooking up the communicating wires with a 4-wire system. As we move around the board to the left, we see we have our thermistor sensor terminals, and this is where we'll hook up our sensors. A liquid line, LL would be liquid line, AMB would be ambient or outdoor sensor, DIS would be discharge line sensor for advanced functions. As we move around the board, we have a last error button that you can depress to retrieve the last 5 errors on the board. Now, it should be noted that if you hold that last error button down for about 10 to 15 seconds, you will clear the memory. Below the last error button, we have 2 LEDs. One of them is red, one of them is green. Those 2 LEDs are status LEDs. Those LEDs will flash different flash codes based on the fault that's being detected on the board. The red LED will flash or stay steady. The green LED will flash or stay steady. So looking at the combination of flashing or steady on the red and the green LED will give you a particular flash code. Now, to find out more information, please look at the service information and the technical information with the equipment to determine what those flash codes mean. Towards the top of the board, we have a compressor delay jumper. If desired, what this does, it will delay the compressor 30 seconds prior to going into defrost, and it will delay the compressor or shut the compressor down 30 seconds before it comes out of defrost. Now what this is a soft switchover feature. So if this jumper is in the yes or the on position, it will delay the compressor prior to going into defrost 30 seconds and prior to coming out of defrost for 30 seconds. And what it does, it allows that reversing valve to switch slower with less noise. So it's kind of a soft switchover feature. It comes from the factory in the no or off position, which allows full pressure to move that reversing valve. So I recommend we want to make sure to leave that in the no position unless there's a noise issue or unless the homeowner is complaining that they don't like that switchover sound of the reversing valve, especially in defrost. It can be a little bit louder. So if it's objectionable, you have the capability of having a compressor delay if desired. There are the two test functions. Just as we said before, if you jumper those test pins for less than 2 seconds, nothing happens. But if you hold those test pins and you short them together with a coin or a jumper wire for 6 to 9 seconds, it will go into defrost. We do have some configuration jumpers on this board, which we will discuss as a separate session. But in this portion of the program, this is just to give you a physical location so you understand where those configuration jumpers are. We will break that out as a separate session shortly. Along the bottom of the board, we have some outputs to the indoor unit. Specifically, we have a Y2 out. That is to control second stage airflow in the cooling mode of operation. The W2 out is a output to the second stage for second stage auxiliary heat. The W1 out is first stage auxiliary heat output from the board if we're going to allow the board outside to stage our heat strips. In addition, the Y2 out is also a function not only in the cooling mode but in the heating mode of operation. Y2 out will be part of our hot heat pump circuit. As we move around the board, we see we have a BS or bonnet sensor input, and this will be utilized if you have a dual fuel, or more specifically, if you have a furnace with a heat pump outside. You have the capability of having an optional bonnet sensor, which is going to actually look at supply air temperature from the furnace in the heating mode of operation. Along the bottom of the board, about midpoint on the board, are your low voltage inputs. And those low voltage inputs will have, this is where you'll hook up your conventional thermostat if you're hooking this board up for 24 volt. Now it should be noted that there's going to be pigtails. There's going to be about 6 to 8 inch pigtails and colored wires that you'll hook your thermostat to on the board if you choose to hook it up 24 volt. Next to the low voltage inputs to the left is your HSP. That's your high pressure switch input from the high pressure switch. So the board will monitor the high pressure switch as a safety circuit. Next to the high pressure switch are contactor outputs, and based on the equipment that this board is found on, either single stage or two stage equipment, you'll have 1, 2, or more of those terminals energized based on the function of the board. And the staging, if you have a two-stage piece of equipment, you'll have more of those terminals hooked up. But this is where your contactor coil will hook up for compressor operation. Coming around the corner of the board, you have RV. Those RV terminals are going to be your reversing valve output, and we're going to energize the reversing valve in the cooling mode of operation on the Champion equipment. So RV reversing valve output, 24 volts, we energize in the cooling mode. Right above those terminals, you have LPS. This is your low pressure switch input. Now this is a very unique feature about the Champion product, which I like a lot. We actually monitor both the high pressure and the low pressure switch separately so that we can troubleshoot and we can monitor those switches separately for advanced functions, troubleshooting functions. Now, unlike our competitors, some of our competitors, they hook the high pressure switch and low pressure switch electrically in series. So if a technician has that fault, he's got to unwire, or he has to break the wires on both of those switches and test them individually. However, on our product, on the Champion product, we monitor them separately so we can actually have a separate flash code for high pressure switch lockout or low pressure switch lockout, which is a very, very nice service feature. As we move up to the side of the board, we see we have an outdoor fan and crankcase heater, compressor crankcase heater switching contacts. Now, team, please remember these contacts are high voltage, so please coach your contractors and our customers that if they're going to be touching or handling this board, we always recommend to shut the power off outside to de-energize those high voltage contacts for safety. Now remember, team, because they are high voltage, it's a safety issue to make sure those are de-energized. We can't stress that enough. De-energize those contacts by shutting the outdoor disconnect off for safety, because those are high voltage contacts for outdoor fan and compressor contactor heating switching contacts. So let's take a look at our low voltage wiring. Our low voltage wiring, if we're hooking this board up for 24 volt, low voltage, conventional thermostat, we will utilize the pigtails. They're normally 6 to 8 inches long, and they'll be colored wires typically. And so the low voltage wiring will have all of these terminals engaged with pigtails on them to wire up with a wire nut and your low voltage wiring for conventional 24 volt wiring. So C is your 24 volt common. That's one of the wires that powers the board up all the time. It is referred to chassis ground or reference to chassis ground. So C is 24 volt common. Y1 is our first stage compressor call from the thermostat. So if we have a two-stage piece of equipment, Y1 will be our first stage compressor operation. Y2 will be our second stage compressor operation if we have a two-stage piece of equipment. For instance, like the HL19 would be a good example. The Y2 would be your second stage compressor operation from the thermostat. Demand from the thermostat, second stage compressor. The O terminal, remember team, O terminal is our reversing valve on our heat pumps, on our Champion heat pumps, and it will be energized in the cooling mode of operation. W is a supplemental heat demand from the conditioned space. Now team, this is an important concept. We take from the thermostat, we go directly outside with auxiliary heat demand. We don't even touch the air handler or the furnace. We're going to let the outdoor unit do that. We're going to let the outdoor unit stage the heating inside based on outdoor air temperature is the most efficient way to do it. So W from the thermostat goes directly outside to W on the advanced defrost control for supplemental heat demand from the conditioned space. XL is a 24 volt output from the control board outside for fault reporting. Now it should be noted that if your thermostat is not equipped with a fault LED or a fault reporting LED, just cap that wire off. Don't even use it. However, if the thermostat is capable of a fault reporting, one of the options that we give you on our Champion equipment is the fact that we can actually flash an LED inside if there's a problem on the board outside. And we do that via the XL wire. So the XL terminal is a fault reporting feature that will flash a fault LED, if so equipped, on the indoor thermostat if there's a fault outside. If the thermostat is not equipped, or if the contractor does not choose to use that fault reporting feature, he can cap that wire off outside. It has nothing to do with the function of the board. It's strictly a fault reporting feature if desired. Our terminal is 24 volt hot, feeding the board and powering the board up outside, 24 volt hot. That's typically a red wire. The BS terminals, the BS or bonnet sensor terminals, will be used for an optional dual fuel or furnace operation. Now it should be noted, team, the BS or the bonnet sensor is a leaving air sensor that's mounted on the underside of the evaporator coil to read or to monitor the furnace output air temperature. And so this optional bonnet sensor can be utilized for a dual fuel application. Y2 out on the outdoor unit. Y2 out controls second stage airflow on the indoor unit, and this is part of your hot heat pump feature. Now the hot heat pump feature is very unique to our Champion equipment in the fact that it allows the outdoor unit to reduce the airflow inside to give us warmer air on a heat pump. One of the largest complaints that we have about heat pumps is the fact that the air seems to be blowing cold out of the register in the heating mode of operation. So this Y2 output, what it does, it'll actually limit second stage airflow inside, but the heat pump will be running at full stage outside. And what that does, that gives you much warmer air temperature coming out of the register. So that hot heat pump feature is a very nice feature on our Champion equipment, but we're going to utilize the Y2 output to control second stage airflow on the indoor unit if we so desire the hot heat pump feature. W2 out from the control board outside in the heat pump will control our second stage auxiliary heat. We'll stage our second stage auxiliary heat based on outdoor air temperature via W2. W1 out is our first stage auxiliary heat, and again we'll utilize our outdoor unit. One of the nice features about our Champion Advanced Defrost Control is it allows us to stage our auxiliary heat based on outdoor air temperature outside. So we'll do that via the W1 out and the W2 out on the control board outside. Now, we talked earlier about some jumpers, the advanced defrost control jumpers. Let's take a look at those jumpers now as a separate session, as we have the capability of configuring the board for some advanced operation. The first one we're going to talk about as we take a look at our PowerPoint presentation is what we call low temperature cutout. The low temperature cutout, you'll notice that there's a big long line of pins on the defrost control, and they're labeled LTCO and BP. Let's talk about the LTCO. Now specifically, the low temperature cutout is the lower jumper on this big line of pins and jumper pins. And so we notice that there's a temperature range from minus 10 degrees all the way up to 45 degrees along those temperatures selections. So the low temperature cutout, it will always be the lower jumper. The lower jumper is your low temperature cutout. So if you move that low temperature cutout, for instance, if you move that up to the 0 degree position, what that means is that the compressor will not run below 0 degrees temperature outside in the heat pump mode of operation. If you move that lower LTCO jumper up to 20 degrees, then you'll notice that if you were to move that to 20 degrees as an example, the compressor would not run below 20 degrees. So the way to think about the low temperature cutout jumper, that lower jumper, wherever you move that lower jumper, the compressor will not run below that temperature selected. In addition, on that same line of jumpers, we have an upper jumper, and that upper jumper will always be the balance point jumper, Now, it should be noted, team, as you take a look at that upper jumper, we have it selected at 35 degrees in our example on our screen. It's actually the middle of the jumper that lines up with the temperature. So when you move that jumper, make sure that the middle lines up with the desired temperature. Now, in our example, that upper jumper, which is our balance point jumper, is set at 35 degrees. Now, the best way to think about that is this. Anything above 35 degrees, you cannot have or you will not have auxiliary heat. So in other words, it's an auxiliary heat lockout jumper. So wherever that upper jumper is, that balance point jumper is, the heat pump will be running all by itself anything above that jumper set point. So in our example at 35 degrees, anything above 35 degree outdoor temperature, the heat pump is running by itself. And even if the homeowner was to go over and set the thermostat up to, say, 90 degrees inside the house, if the temperature outside is above 35, it will run on the heat pump only. However, if the outdoor temperature is below 35 degrees, then the control board will have the capability, if it's below 35 degrees in our example, the control board will output W1 and W2 signals to bring on auxiliary heat. So the best way to think about that upper balance point jumper is an auxiliary heat lockout jumper. If it's above the selected jumper set point, you do not get auxiliary heat, and you only have heat pump above that point. However, if it's colder outside than the jumper selection set point, then it will allow auxiliary heat to come on with the heat pump. So that's an important concept, and it's really there for comfort. So be wise when you set that up, based on the homeowner's lifestyle. They may not want it to be too cool before the auxiliary heat comes on. So talk to the homeowner, coach the contractors on talking to the homeowner and find out where it's best for them to have that balance point jumper for optimal comfort. As we take a look at our PowerPoint selection a little bit closer, we see our next feature. We're going to look at our defrost curve. That defrost curve is actually going to be a part of the engineered programming on the board to bring defrost on at the proper time. Now, it should be noted that on the bottom of those pins, you see there's a label that says PRGM. That's program from the factory. So the factory boards will always have a PRGM jumper on the programmed position. However, on a replacement board, you'll select either jumper position 1, 2, 3, 4, 5, or 6 based on the tonnage of the outdoor unit. And please look at your install information that comes with a replacement board for the proper selection on the defrost curve. The important thing we need to coach our contractors on, team, is this: leave it alone. If it's a factory board and it's on PRGM, that's the factory program, leave it alone. Next to the defrost curve jumper, we have one called Y2 lock, and the selection is on or off. It comes from the factory in the off position. If it's moved to the on position and the outdoor unit receives a call for second stage or Y2 compressor operation, it will lock it in to second stage to complete the call. So from the factory, it's in the off position, but if that jumper is put into the on position and the outdoor unit receives a Y2 or second stage compressor call, it locks it in to complete the call until the thermostat is satisfied. If it's in the off position, what it will do is it will allow the outdoor unit to cycle Y1 first stage, Y2 second stage, back to Y1 first stage, back and forth based on thermostat activity. So it's important to note, again, one more time, that if you do have this in the on position, the Y2 lock jumper in the on position, and the outdoor unit gets a second stage call, it's going to lock it in to second stage to complete the call until the thermostat is satisfied. Next to the Y2 lock jumper is a fossil fuel. This fossil fuel jumper comes from the factory in the off position, but if you're going to hook the outdoor unit up to a furnace inside, you have the capability of telling the board it's a fossil fuel or it's hooked up to a furnace inside, and it gives you some functions for fossil fuel control. Next to that is our hot heat pump feature, on or off. If you want to utilize the hot heat pump feature, you would put that in the on position, and then that would then allow control via the Y2 output that we talked about earlier to control second stage airflow in the heating mode of operation if you desire hot heat pump feature. It comes factory in the off position, but if you want that hot heat pump feature and utilize that Y2 output to control the second stage airflow, you'd put that in the on position. And then finally, the hot heat pump switch point. The hot heat pump switch point will be a place that you can, you have a 35, 40, or 45 degree jumper selection. It's field selectable. And so this would allow the technician to set up when hot heat pump would be appropriate. So if it's 35 degrees, 40 degrees, or 45 degrees outside, then the technician can select when hot heat pump would be selected. Now some of those features that we talked a little bit about earlier with the advanced defrost control, that when we go into defrost cycle, we're going to energize W1 out 30 seconds prior to the defrost cycle. So we kind of preheat the air before we go into defrost. And then during defrost, we'll have Y1 out, our first stage auxiliary heat during defrost. And then we'll continue to let that Y1 or first stage auxiliary heat stay on for 3 minutes after the end of the defrost cycle to temper the air and to prevent the space from getting overcooled during defrost. Now it should be noted, Y2 out or W2 out would only be energized if W1 out has been on for 15 minutes. So remember, team, the outdoor unit is going to provide a W1 out for defrost, and only W2 out would be energized, or auxiliary heat W2 would be energized if you had a 15-minute timeout. Now, if the homeowner should go over to the thermostat and go to emergency heat, in other words, they're telling the outdoor unit to not run, they're going to be running on auxiliary heat only. So if you're above that balance point that we talked about earlier, and we go to emergency heat, we will have a W1 out immediately. In other words, we'll have our first stage auxiliary heat come on immediately. Then, if the call for emergency heat is still there 15 minutes later, we would then energize W2 out for second stage auxiliary heat. Now watch this. If we're below the balance point, or that balance point jumper that we discussed earlier, in our example, we have it set at 35 degrees. You can see on the screen. We have that 35-degree balance point jumper set at 35 degrees. If it's below 35 degrees in our example, and the homeowner goes to emergency heat, and the compressor is de-energized because we've killed the Y signal with emergency heat. If we're below balance point, W1 and W2 out are energized immediately. So we get all of our auxiliary heat if we're below that balance point. So remember, emergency heat, if the homeowner goes to emergency heat, they disable the compressor and they're running strictly on auxiliary heat. And if we're above that balance point, we get W1 out, and then 15 minutes later we get W2. But if we're below the balance point outside that we have selected, in our example 35 degrees, and the homeowner goes to emergency heat, they get all the auxiliary heat at one time. Team, as a quick reminder, the open circuit voltage on our sensors is going to be 4 to 5 volt DC. If we remove the sensors from the board on our advanced defrost control, we will still have 4 to 5 volt DC on our sensor terminals without the sensors plugged on. Now, as a quick reminder, the advanced defrost control has 3 sensors. It has an ambient outdoor air temperature sensor. It has a coil line sensor. It's going to be mounted on the liquid line. And a discharge line sensor is going to be on the hot gas line of the compressor. Now, in our previous module that we just did, Module 3, we talked about checking those sensors, but as a quick overview, one more time, 10,000 ohms at 77 degrees is our nominal calibration point for all of our sensors. In addition, we provide you some charts with your handouts or your workbook, and those charts, we'll review those again real quickly just to remind you which ones you have. But on those charts, you're going to be utilizing some voltage and ohms and some temperature readings. So, as a quick reminder, one more time, you're going to need a high-quality voltometer with DC measurement capability, and we recommend needlepoint meter leads, and a good high-quality electronic temperature probe, and we recommend a temperature clamp as well. And we had reviewed earlier in Module 3, today, the charts, but again, you do have a ambient outdoor temperature chart in your handout or your workbook. You will also have a bonnet and liquid line sensor chart. You'll also have a discharge line sensor chart in your handout or your workbook. And so one more time, just as a quick overview or a final example, let's say, for instance, if we look at our discharge line sensor chart, and let's say our discharge line sensor is reading 160 degrees. Let's say it's subject to 160 degrees off the chart. If I remove that sensor from the board at 160 degrees, I unplug the sensor from the board, I should read 1,693 ohms. If I plug the sensor back onto the board at 160 degrees, that same sensor would read 2.49 volt DC plugged back onto the board. So remember, team, when you're looking at sensors, as a final review on sensors, as you're looking at sensors, there's 3 tests. You're going to check to make sure the board has 4 to 5 volt DC without the sensor plugged on. You're going to unplug the sensor and take the temperature that sensor is subject to. You're going to unplug the sensor and then ohm the sensor out, or look at the resistance in ohms on the sensor with it unplugged from the board. You'll then plug the sensor back onto the board and read the DC voltage of the sensor plugged back onto the board. Well, I want to thank everyone today for your attendance. This is a recorded session, and if this was a live session, we would be asking for final questions or comments at this time. But because this is a recorded only session, we just want to thank you for your attendance today. Thank you for looking at our recorded session, and by all means, please call me or any of our team members if you have questions or comments moving forward, and we certainly look forward to having you attend as well some of our live sessions. Thank you.